The beauty of physics lies in understanding its equations. Very simple equations like acceleration and velocity. It helps us to dig deeper about the understanding of the nature around us. Physics is basically applied mathematics, and this simple value of g, that is gravitational acceleration, and how it would have been derived would help us to further understand the true nature of gravity. We have been in a habit of taking the value of g as 9.8 meter per second square for Earth in general for most of the calculations. But why is it 9.8 meter per second square, and why is it termed as a constant and not anything else? Why doesn't it vary? So to dig deeper, let us take a very few simple equations that are well known. One of them being acceleration, which is equal to final velocity minus initial velocity divided by time. So basically it is talking about the change in velocity upon time. Velocity itself is displacement per time. So whatever change in your position you make, that is displacement divided by time, is called velocity. And then you need two values. One is final velocity and the other is initial velocity, and its difference divided by time to understand what is acceleration. Now g is gravitational acceleration, so it is talking about acceleration due to gravity, and it is taken as 9.8 meter per second square. Why is it so? Let's dig deeper. Let's take a case. Let's take an object with the initial position as marked over here at height h from the ground. So this object in particular, it is hanging still at a height h from the ground. It is still over here. It's not moving right now. It will move once we start the ticking of the clock. That is at time 0, its position is at the top at height h from the ground. As soon as we let this object fall towards the ground, it should start moving downwards. Now over here we are not considering any friction from air or any other parameters like wind. Let us assume that this particular object is right now in a vacuumized environment and it's not having any kind of friction because of air around it. At t is equal to 0, that is at initial time, its position is at the top. Its height is h from the ground. Now as we let it move down, here is the case 2. So this was the initial position. Now it has started to move down. And let us suppose it is taking t amount of time. Let us suppose it takes t seconds to move from this initial position to its final position wherein it has touched the ground. So if this travel is made in time t seconds, and if it has covered some h meters, then obviously the average velocity for this travel would be total displacement, that is h in this case, divided by time. So h upon t would be the average velocity for this travel. Now mind well, here the velocity was 0, right? Because initially it wasn't moving, as in case 1, right? At time t is equal to 0, it wasn't moving, so its speed or its velocity, the initial velocity over here, would be 0, right? Its velocity will be maximum when it was just about to touch the ground. So just before touching the ground, its velocity would have been maximum, and that we would be considering as final velocity, right? We know that its average velocity during this travel is h divided by t. Would have been 0 over here, would have reached its maximum, its peak at this place, it's at its final position. So during this travel, It would have increased its speed from 0 to maximum. We know that its average is this. We don't know what is the maximum speed or maximum velocity over here. But it is quite obvious that if the average is known to us, and if we know one of the parameters, that is its initial velocity is 0, in that case the maximum would be twice the average velocity, right? Initial velocity is 0 over here. Final velocity would be twice the average velocity, because if you figure it out over here, average velocity is final velocity plus initial velocity divided by 2, right? But over here, initial velocity being 0, final velocity being 2h divided by t, you will end up getting h divided by t if you try and sum this up, initial velocity and final velocity divided by 2. So 2h upon t plus 0 divided by 2, you will end up getting h by t. That is the average velocity. But what we have done over here is we have taken final velocity as twice the average velocity, just because of the knowledge of initial velocity being 0 and average velocity being h divided by t. Now we already discussed about acceleration being final velocity minus initial velocity divided by time. Now that we know the time of travel, now that we know the initial velocity and the final velocity being 2h upon t, we can find the acceleration as final velocity minus initial velocity divided by 2. You will end up getting 2h divided by t, that is this value, minus 0. So here this minus 0 divided by t. So if you subtract 0 from 2h upon t, you will end up getting 2h upon t divided by t. So since both these terms are in denominator, you get 2h divided by t square, and thus you get value of g is equal to 2h divided by t square. Now you won't be able to see any kind of elements like mass or size of the object, and thus the value of g, that is the gravitational acceleration, is constant in a sense. If you take a piece of cotton or a piece of iron of the same size, both of them will fall at the same rate, at the same accelerated acceleration while moving down towards the ground. This is independent of mass, and this particular thing, as we have already discussed, we assume that this particular cases were studied in absence of air, that is in the vacuum. So if you try and have an object in the vacuum over the surface of the earth, and if you do this experiment with any object, be it a cotton ball, be it a steel ball, be it as heavy as an aeroplane, or be it as light as a feather, you will get this equation to help you out and get this value. G is equal to 9.8 meter per second square. And you also get the gist of the unit for the value of g. You get 2h upon t square. H is height, so its SI unit would be meter. T is in seconds, so t square would be second square. So you get meter per second square. You perform this experiment in vacuum over the surface of the earth, and you will get the value 9.8 meter per second square for all the things that you try out during the experiment in the place of the object. That's the beauty of physics.